Hello everyone, welcome back to my channel. So today we are going to discuss photoelectric effect in this video. So before moving forward with the topic, if you haven't subscribed the channel, then please subscribe the channel and don't forget to press the bell icon. Now let us discuss what is photoelectric effect. Okay, so we are going to discuss it with the help of this diagram. So this is a metal surface. Okay, this is a metal surface, and when photon of frequency which is above a particular frequency, which is called the threshold frequency, is incidented on a metal surface, then electrons are ejected out from the metal surface. Okay, so these are electrons. So these photons are incident on a metal surface, and the frequency of this photon is greater than a particular frequency. Now this particular frequency is threshold frequency, which depends upon the nature of this metal surface we are using. Okay, it varies from material to material, metal to metal. Okay, so when these photons are incident on a metal surface, without any time lag, electrons are ejected out from this metal surface. Okay, so these electrons are called photoelectrons, and this entire effect is called photoelectric effect. Okay, now let us discuss the experimental setup of the photoelectric effect. So this is the metal plate, this is the collector plate. Okay, so when the photons are incidented on this metal plate, what happens? Electrons are ejected out from this metal plate. Okay, so when these electrons reaches this collector plate, okay, now this collector plate is connected to the positive terminal of the battery, and the metal plate is connected to the negative terminal of the battery. So these electrons which are negative charged will get attracted towards the collector plate, and that is why it is called collector plate, because it is collecting these electrons towards it. Okay, so when these electrons will reach this collector plate, the current will start flowing in this entire circuit. Okay, so this current is called photoelectric current. Okay, now this wiring we have done, this is actually sign changer. Okay, now the function of this sign changer we are going to discuss in the section where we will discuss the stopping potential. Okay, so when we'll discuss this stopping potential, we are going to discuss this sign changer, the effect of this sign changer thoroughly. Okay, simply here briefly we can say that this sign changer is used to change, for example, if we want to connect this metal plate to the positive terminal and the collector plate to the negative terminal. Okay, so this is used just to interchange the terminals of the battery with this plate and collector between them. Okay, so this sign changer we are going to discuss when during the discussion of the stopping potential. Okay, now what are the experimental results of this experiment? Okay, now in the experimental setup, this is ammeter, this is key, and this is resistance. Okay, and we have connected the battery with EMF V. Okay, now the experimental results were, first was work function. What is work function? Work function is the minimum energy which is required to eject the electron from the metal surface. Okay, and this minimum energy depends upon the material we are using, depends upon the metal we are using. Okay, and this work function is denoted by phi. Okay, so phi is equal to h nu naught, where this nu naught is the threshold frequency. Okay, the minimum frequency which is required in order to eject the electrons from the metal surface. Okay, next result was the photoelectric current was directly proportional to the intensity of light. Now what does intensity of light mean? Okay, intensity means the number of photons which are incidenting on the metal surface. Okay, so when we'll increase the number of photons on the particular metal surface, apparently the number of electrons ejected will also increase, and this will result in the increase of photoelectric current. So in this way, photoelectric current and the intensity of light which is incidenting on that metal surface are directly proportional. Okay, so this is photoelectric current, this is intensity, and they are directly proportional. Now what does this dotted line mean? It means that since the electrons will not get ejected unless and until the frequency of the light is greater than the threshold frequency, right? So initially there will be no current, okay, then gradually the current will increase with the increase of the photons which are incidenting on that particular metal surface. Now what is stopping potential? Okay, so here we are going to discuss the function of that sign changer. Okay, so now let us move back to the sign changer. So this is sign changer. Okay, so when we'll invert the terminals, or when we connect this metal plate to the positive terminal and this collector plate to the negative terminal, okay, the electrons will get repelled from this collector plate. Okay, so the potential which is required so that the electron, even with this maximum kinetic energy, cannot reach this collector plate is called the stopping potential. Means the potential which is required to stop the electron with the highest kinetic energy from reaching the collector plate is called stopping potential. Okay, so this is the function of the sign changer. It will invert the terminals of the battery, or we can say the metal plate and the collector plate. Okay, so the potential which is required to stop the photoelectron to reach at collector plate is called stopping potential. Okay, now this stopping potential depends upon the frequency of the light we are using. Okay, so V0 is equal to A nu plus B, where B depends upon the material, upon the nature of the material, and A is a constant. Now let us discuss the graph between this stopping potential and the incident frequency. Okay, so this is nu naught, means the stopping potential, and this is frequency. If we compare this equation with the equation of line, what we'll get, A is the slope of the straight line and B is the intercept. Okay, since B depends upon the nature of the material, so the intercept will change for different materials, but the slope will remain same. Okay, so suppose this is one material, and this is second material. The slope of both the material is same, but the intercept is changing. Okay, now the fourth result of this experiment was there is no time lag between incident of photon and the ejection of electron. What does it mean? Now the photoelectric effect is actually explained by using particle nature of light. Okay, it cannot be explained by using wave nature of light. Okay, so since we are using particle nature of light, it means there is no time lag, there will be no time lag between incidence of photon and ejection of electron. Since we can see when a particle strikes another particle, their interaction or their collision, the effect of their collision will occur at the same time. There is no time lag between them. So the photoelectric effect, since we got this result that there is no time lag between the incidence of photon and ejection of electron, it means this effect can only be explained by using particle nature of light. Now Einstein gave the explanation for this photoelectric effect. Let us see what was that explanation. He said that the light which is incident on the metal surface is divided into two parts. What was that two parts? First was the work function, means which is dependent upon the material we are using, dependent upon the metal we are using. Okay, so first was the wave function and second was the kinetic energy. So the entire energy of the photon which is incident on the metal surface is converted into the work function of the metal surface plus the kinetic energy of the electron. Okay, so from this equation what we can say, that kinetic energy is equal to h nu minus phi, where phi is the work function and Ke is the kinetic energy and h nu is the energy of the photon. Now let us suppose that the threshold frequency of that particular metal is nu naught. Okay, and we know that work function is denoted by h nu naught. So when this frequency is exactly the incident, the frequency of the incidence photon is exactly equal to the threshold frequency, what will happen? There will be no kinetic energy provided to the electron. Okay, so electron will get just ejected from the metal surface. It will not gain any kinetic energy. So kinetic energy will be 0 and work function is h nu naught minus phi. Okay, sorry, work function is phi, h nu naught, since nu is equal to nu naught for the threshold frequency. So this implies that the work function will be equal to h nu naught. Okay, now if we substitute the value of work function in this equation, what we'll get? Kinetic energy is equal to h nu minus h nu naught. So from here we can say that the work function is equal to the is dependent upon the threshold frequency, and which is equal to h into nu naught. Here h is the Planck's constant. Okay, now the second thing was, what is stopping potential? Okay, we can derive it. What is stopping potential? It is the potential which is required to stop the electron with maximum kinetic energy, okay, from reaching the collector plate. Now let us suppose the maximum kinetic energy of the electron is half mv max square. Okay, V max denotes the maximum kinetic energy, which is equal to E V naught. V naught is what? Stopping potential. Okay, now from here, by solving it further, what we'll get? V naught is equal to h upon E nu minus h upon E nu naught. Now here h nu naught is what? Work function. Okay, so from here stopping potential will be equal to h nu upon E minus work function upon E. Okay, so from here if we compare these both the equations, since while defining the stopping potential we said V naught stopping potential is equal to A nu plus B, right? So from by comparing both these equations, what we'll get? This slope is h upon E and the intercept is minus phi naught upon E, or we can say minus h nu naught upon E. So let us plot this this curve. What will happen? Since it is a straight line, so this is stopping potential, this is nu, and this is our straight line. Okay, why it is touching this negative part? Because the intercept is minus h nu naught upon E, it is negative, and the slope is h upon E. Okay, now let us conclude. So whatever happened in this photoelectric effect, let us conclude it. What is the conclusion of this experiment? The conclusion was, if the intensity is large, what does this mean? That the number of incident photon is large, then the electron ejected will also be large, and which means that if electrons ejected is large, then the photoelectric current is also large, which implies that the photoelectric current is directly proportional to the intensity of the light we are using. Okay, next is, this event is based on particle nature. We have already discussed it. Thus there is no time lag between incidence of photon and ejection of electron. Okay, so now the entire photoelectric effect is completed. I hope your all doubts related to photoelectric effect is solved in this equation, in this video. And if you have any doubt related to this topic, you can write it in the comment section, and if you like the video, then give it a thumbs up. Thank you so much for watching the video.